The SOHO spacecraft has recorded the effect of all this rising energy. Its ultraviolet sensors show a wavy pattern of gas on the Sun's surface, along with the super-hot halo of gas called the corona. The white regions are places where the rising gas suddenly escapes. Immense loops of ionized gas, 10 times the diameter of Earth, rise and fall back. These solar prominences are hot, about 60,000 degrees Celsius. But there are times when the release of energy on the solar surface gets bottled up by magnetic fields generated by the Sun's spinning turbulent core. Using data from the Sun's exterior, scientists have modeled these fields as they erupt all around the Sun's surface, twisting and looping. Heat rising towards the surface follows these magnetic field lines, which can also stifle the rising columns, forming relatively cool patches. That's where sunspots form. 4 centuries ago, Galileo Galilei was the first to argue that these blotches were actually on the Sun's surface, though he suspected they were clouds. Their nature remained unclear until 1908, when astronomer George Ellery Hale demonstrated the link between sunspots and intense magnetic fields. Over the years, scientists have drawn their strange shapes in an effort to understand them. What they didn't see until recently was the heat and pressure building around them. Using data from the Solar and Heliospheric Observatory, SOHO, scientists are learning to read undulations on the surface of the Sun, the result of pressure waves ricocheting through its volume. Like the study of earthquakes on Earth, this field, called helioseismology, is a window on the movements of gas inside the Sun. It's also generating predictions of flares and sunspots, including those forming on the far side. Detectors aboard the SOHO spacecraft have managed to catch the moment when the energy kept by a sunspot is suddenly released. A shock wave travels rapidly outward, like a solar tsunami, with enough force to circle the star. That signals the start of a coronal mass ejection, or CME, a massive eruption of particles and hot gas. With a coronagraph to block out the bright light of the Sun, you can see how violent our Sun can get. If a CME is detected blasting out from behind this artificial eclipse, you know that satellites and power systems on Earth are going to get hit hard, especially if it has been launched in the direction of where Earth will be in its orbit in about 24 to 36 hours. The Sun sends a wave of energetic particles that will crash into Earth's magnetic field. And as more and more of the ground around Earth gets carpeted with conductive metal, the chances are that all the juice will fry something vital to humanity.